So alright guys, so now we are going to talk about the section 6.3, trigonometric equations number 2. So the big idea is the trigonometric function have to have the same argument. So I will let you read to solve a trigonometric equation what you have to do, and let's jump on a practice. First of all, I would like to remind you that you can always use your calculator to find the zero of your function, but let's try to work this out with 2 cos of x divided by 2 minus square root of 2 equals 0. So the first thing you have to do is to have the square root of 2 on the other side. Then you are going to divide by 2 both sides, and if you divide by 2 both sides, you have cos of x of the angle x over 2 equal square root of 2 divided by 2. So what the angle is giving you the value of the cosinus of this angle equal to square root of 2 divided by 2. I would like to remind you x over 2 is an angle. Okay? So if you had cosinus theta equals square root of 2 divided by 2, well, very easily you would say that theta equal pi over 4. Okay, so in that case, x over 2 equal pi over 4, and so therefore, x equal pi over 2, because you multiply by 2 both sides to get rid of the 2, and so you end up to have pi over 2. All right? And obviously, you can always have the angle being equal to negative pi over 4, okay, which is, you could have also theta could be equal to negative pi over 4, which is 7 pi over 4 when you are going counterclockwise on your trigonometric circle. And you end up to have x equal 7 pi divided by 2. When you look at the graphic, you can see that at x equal pi over 2 you have a 0, and when you are at x equal 7 pi over 2, you have another 0 right here. Okay? So let's jump on the second problem. On the second problem, we have cosinus 2x equals sinus x. So, two trigonometric functions. So we have two trig functions and two arguments. We have 2x and x. So we are going to use double angle identity. We are going to use the double angle identity for cosine. Okay? Why? Because by doing so, we are going to change the cosine 2x into an expression made of only with sine, and therefore we're hoping to have an equation made only with sinus. I know that 1 minus 2 sinus square of x equal cosinus 2x. So 1 minus 2 sinus square of the angle x equal sinus x, because I substitute cosinus 2x by 1 minus 2 sinus square x. So now it's pretty easy, because I'm going to move everything from the left to the right, okay, by subtracting 1 and adding both sides 2 sinus square of x, subtracting 1 and adding both sides 2 sinus square of x, and I end up to have 0 equal 2 sinus square of x plus sinus x minus 1. And if I want to rewrite that in a more usual way, I will have 2 sinus square of x plus sinus x minus 1 equals 0. That look like a 2x squared plus x minus 1 equals 0 with capital X equal to sinus x. If I factorize this equation, I could use a quadratic formula to find the value of lowercase x, or actually capital X, and then find lowercase x by using my inverse function. But in that case, I can factorize my equation. So if I look at my equation of 2x squared plus x minus 1 equals 0, I can easily realize this is 2x minus 1 multiplied by x plus 1. And so using the zero product property, I end up to say that the first parenthesis could be equal to 0, or the second parenthesis could be equal to 0. The first parenthesis bring me to capital X equal 1 over 2. I know that capital X equal sinus of the angle lowercase x equal 1 over 2. And that implies that x equal pi over 6, 5 pi over 6. When for the other one, I end up to have x, the capital X equal negative 1. And that defined sinus of the angle lowercase x equal negative 1. And that means lowercase angle x equal 3 pi over 2. All right? I hope you realize it's not very complicated. And if you look at graphically, what do we have? We have pi over 6. So we're having pi over 6. Let me pi over 6 will be in red, 5 pi over 6 will be like this, and the last one will be in green. So pi over 6 will be in red, that's pi over 6. Then we have 2, 3, 4, 5 pi over 6 right here, we should be in orange. And then we have 3 pi over 2, and 3 pi over 2 is in green. All right, and repeating. Okay, so problem number 3. I'm going to let you do the problem number 3 by yourself. Try to work this out. Obviously, you need to use the Pythagorean identity. So the first thing is maybe use the Pythagorean identity. And 2, you could use the double angle identity also. So could use the double identity, double angle identity. Okay, so try to do, well, actually, you know what? I'm going to do the Pythagorean identity with you, and you will do by yourself the double identity. So you are going to do on your own the double, using the double angle identity, and I'm going to do with you the Pythagorean identity. So we have is 2 cos square of the angle theta minus 2 sinus square of the angle theta plus 1 equals 0. Well, cos square theta is equal to 1 minus sinus square of the angle minus 2 sinus square theta plus 1 equals 0. Now you are going to distribute 2 minus 2 sinus square of the angle minus 2 sinus square of the angle plus 1 equals 0. Therefore, you end up to have negative 4 sinus square of the angle theta plus 3 equals 0. So sinus square theta negative 4 equal -3. So I divide by -4 both sides. End up to have -3 over -4, which is 3/4. And so I end up to have sinus of the angle equal plus or minus square root of 3 divided by 2, because I take the square root of 3/4, which is square root of 3 divided by 2, plus or minus, because remember, when you have x squared equal a, x is supposed to be equal to plus or minus square root of a. Okay? And so that implies that the angle theta will be equal to pi over 3, 2 pi over 3, could be also 4 pi over 3, 5 pi over 3, etc. All right? So I'll let you do the double angle identity, and you are going to find exactly the same value of theta to solve, that will solve this equation. All right. Number 4, and the number 4 is cotangent 2x minus cosec 2x equal 1. So what I would do is I would transform, and I would express the cosec of the angle 2x in terms of cotangent. So step number 1 is express cosec of the angle 2x in terms of cotangent. So what you are going to do is you are going to rewrite cotangent of the angle 2x squared plus 1 equal cosec square of the angle 2x. That means that the cosec of the angle 2x equal the square root of cotangent square of the angle 2x plus 1. You are going to substitute cosec 2x that you just found, this expression right here, inside your equation, and then you will solve your equation. I'll let you do that, and we will work in class more problem. Thank you.